So, hello everyone. This is my binary search tree implementation for the data structures class. Um, I'm gonna be walking you through some challenges I faced and how it works. So, first, let me show you what it does. Give me a sec. So, you can see it inserts numbers. It searches for them. It deletes them and shows different ways to walk through the tree. So let me break down the important parts. I split this into three files, which is the binary tree C++, the binary tree header file, and the main.c++. The main.c++ just tests everything, calls everything. The binary tree header file has all the declarations, and the binary tree C++ file has the actual implementations. I made a tree node struct inside the class. Each node stores a number and has pointers to its left and right children. Um, the tree itself just needs to track the root node. So, starting with insertion at first, the way it works is it adds numbers recursively. So if the new number is smaller than the current node, then it goes left. If it's bigger, it goes right. The tricky part here was getting the recursion to work properly. Um, I kept messing up with the statements at first. I had to make sure that each recursive call properly updates the child pointers. Um, as for the search function, the search function is pretty straightforward. It follows the same left-right logic until it finds the number or hits a dead end, and it either returns found or not found, or true or false. Um, for the deletion here, the deletion was, I would say, the hardest part because there's three cases. The first case is when the node has no kids, which is easy, you just delete it. When it has one kid, you need to connect the parent to that kid. And then when it has two kids, you need to find the smallest number in the right subtree to replace it. Um, I struggled with the third case when it has two kids. I kept getting memory leaks until I realized I needed to copy the value before doing the delete, the recursive delete. Um, as for the traversal, there is four ways to walk through the tree. The first way would be the in order, followed by the pre order, the post order, and the level order. So, the way that the in order works is it goes left, current, right. It gives you the numbers in order, um, as we can see here, left, root, right, and then this just prints out the traversal. As for the pre-order, um, it goes root, left, right. This is good when you want to copy the tree. The post order goes left, right, and root, or current, and then the level order just goes by levels. It uses a queue, which was new to me. So the first three, in order, pre-order, and post-order. They use recursion, which took some practice to get right. Um, the level order was interesting because, as I said, it uses a queue instead of recursion. And then I have these helper functions here, which are the count all nodes and the tree depth. So it uses two utility functions. Um, Size counts all the nodes. It's just a recursive left plus right plus one, and then the death actually finds how many levels the tree has. Again, um, recursive. So it takes the max of the left and the right depth. Um, my main challenges, I guess, would say were, like I said, getting the deletion right with all the edge cases that I had here. The debugging memory leaks, because, like I said, mentioned I had forgotten to delete the nodes, and understanding how the recursive returns work when inserted. Um, I found it easier for me to. Oh, sorry. These are the values of the tree, and then these are the different ways to walk through the tree. So then there's the in order, pre order, post order, and then the level walk. So this just checks if the values are there. If not, then it's found, not found, as I mentioned earlier. Um, I guess I was able to do this because of something that we had mentioned in class. Um, to draw the tree um, on paper, it really helps visualize what the code should do. And I started small, testing with just 2 to 3 nodes before bigger trees. So yeah, this is my binary search tree implementation. It does all the required operations, and I learned a lot about pointers and recursion through this project. Yeah. So yes, guys, thank you for watching. If you have any questions, just drop them in the comments below. And if you're coming back regularly, consider subscribing.